Good day, everyone. We are the Group 4, and our discussion for today is all about the gel electrophoresis. Have you ever wondered how scientists work with tiny molecules that they can see? Here's your chance to try it yourself. Sort a measure of DNA strands by running your own gel electrophoresis experiment.
You are holding a small plastic tube with some clear liquid in it. You've been told, you've been told that the liquid contains DNA strands of several different lengths. Your job is to figure out what those lengths are. How will you do it? First, if the DNA strands were as big as your shoes laces, you should you could sort them by hand into groups and measure them. But DNA strands are molecules so tiny that you can see them even under most microscope. And these are the way to sort and measure the DNA strands in your tube even though you can't see or touch them. There is it called gel electrophoresis. Scientists use electrophoresis whenever they need to sort DNA strands according to length. This technique is also useful for separating other types of molecules like proteins.
Oh, makapak na na ko yan. Pagkuhan ya, mayor kayo. Madungog mong gagyapon. Pakusgon noon.
The gel is the filter that sorts the DNA strands. It's like a sponge made by gel with any small holes in it.
Isa.
We place DNA sample into holes at one end of the gel. Electrophoresis is how we push the DNA strands through the gel filter. By adding an electrical current, we can make the DNA move. Short strands move through the holes of the gel more quickly than long strands. Over time, the shorter strands in the sample will move farther away from the starting point than the longer strands. Daily strands of the same length will move at the same speed and end up grouped together. In this way, the DNA strands in the sample sort themselves. Staining the sorted groups of the DNA makes them visible to the naked eye. Although we can see a single DNA strand, we can see the large groups of stained DNA strands. These groups show up as band in the gel. Now it's your turn to run a gel. That's a scientist's slang for electrophoresis. Follow along with the steps shown above. Here is what you will need to make it a get. Powder agarose, buffer, a flash, a microwave, the gel mold, and gel pump. Making an electrophoresis gel is a lot. is a lot like making gel, but you wouldn't want to eat this type of gel. Put a small amount of agarose into the flask. Agarose is a dried powder similar to gelatin but made from seaweed. Add some liquid vapor to the flask. The vapor is a salt water solution that will let the electrical charges flow through the gel. With loosely placed plastic wrap over the top of the flask to prevent the liquid from boiling over. Open the microwave by pressing the open button. Place the flask containing the buffer and agarose mixture inside the microwave. Heat the mixture until the agarose melts into the buffer. Remove the plastic wrap from the top of the flask. Pour the melted agarose mixture into the mold. Notice that the mold has stayed on each end and hold in the melted agarose. Place the comb into the gel on one end. The notches is gel mold hold it in place. Let the gel cool and solidify. This usually takes about half an hour, but will speed up the clock for you as the gel holes, tiny holes will form in it. Carefully remove the comb, leaving empty wells for the DNA samples. Your gel is now ready to run. Now it's time to set up the electrophoresis box. You will need the gel you just made, an electrophoresis box, and another bottle of buffer. Pour the buffer into the electrophoresis box. Pla- Place the gel still in the molds into the electrophoresis box. We have removed the tape from the end of the gel molds. The gel should be just barely submerged in the buffer. The buffer conducts the electrical current from one end of the gel to the another. It will also keep the gel from dying out during the experiment. You're ready to load the DNA sample into the gel. Here's what you'll need. Loading buffer, the test tube of DNA, the DNA size standard, a, a micropipector, the electrophoresis box containing buffer, and the gel and pipette tips. What a clean type tips use the micropipectors to suck up some loading buffer, then out into the DNA sample. DNA samples are prepared in a clear liquid solution that would be heard to see if you tried to load it directly into a wheel. The loading buffer contains a dye that makes a sample easy to see. It's also slightly groovy. This makes the DNA sample thicker so that it will drop into the well instead of floating away. Then the DNA size standard already contain loading buffer. Next, you will use the micropipector to transfer the DNA samples from the tube into the well, well of gel.
Bag na lang.
First, suck up some of the DNA sample into the peptide tips. Inject the DNA sample from the pipe into the first well of the gel. Nice job. In real life, bonding the sample into the wells takes some practice, so don't be disappointed if you miss your target for first few times. Using a clean pipe tips, use the micropipe Tor to suck up DNA size standard. Transfer the DNA size standard into the next empty well. The DNA size standard contains DNA strands of known lengths. Running it on the gel will give you a reference by which to estimate the length of the DNA strands in your sample. It's time to turn on the electricity and run your gel. When you turn on the power, the black end will generate a negative charge and the red end will generate positive charge. Together, they will pass the current through the gel. DNA has negative charge. To move the DNA through the gel, you must put the black cord, the negative charge, closest to the wells. Plug the black cords from the electrophoresis box into the matching out outlet of the power supply. Click the location of the power supply. That's right. Now click the location of the power supply where you want to plug it in the red cord. Turn on the power supply. Your gel is off and running. Let's look into the gel box to see what happened. Click for the tiny air bubbles coming out from the electrodes and both ends of the electrophoresis box. These bubbles are your proof that a current is running. Refilled by the negative charge, the DNA moves through the gel toward the positive charge at the other end. Short DNA strands move through the holes into the gel more quickly than long strands. Over time, the shorter DNA strands will migrate farther from the starting point than the longer strands. We can actually see the migrating DNA bands, gray, but we can see the blue dye from the loading buffer as it migrates. You've finished running your gel, where we've taken the gel molds with the gel in it out of the electrophoresis box. The, the time has come to analyze your sample and estimate the length of the DNA strands. First, you need to stain the DNA in your gel using DNA staining solution. The stain is a chemical called ethidium bromide with bind to DNA and shows up under fluorescent light. Although we can see single DNA strands, we can see large group of stained DNA strands. These groups will show up as bands in the gel. Drag the gel out of the mold and put into the DNA staining solution. Because ethidium bromide binds to DNA, it can damage the DNA in your cells. If your stain if you stain a gel is real life, wear gloves and avoid direct contact to your staining solution with the staining solution. It takes about half an hour to stain the DNA in the gel. Well spread up the clap for you. Remove the gel from the staining solution and place it on the UV ultraviolet light box. Turn on the UV box. Ultraviolet light from the Now you can determine the approximate length of the DNA strands in your sample. Compare the bands from the DNA sample with the bands of known length from the DNA size standard. Enter the estimated length in base pairs. For each band in your DNA sample, electrophoresis cannot tell us the exact DNA length and DNA strands, just a good estimate. So give your best guess based on the DNA size standards. Press forward, then you will finish. One or more of your estimated length values is zero. Please enter estimated length for all of the bands in your DNA samples in the input boxes for on to the left of the gel, then press forward. One or more of your answers was incorrect. The estimated length is base pairs. Each of band of your DNA sample is based on how they line up with the bands of known length and in the DNA size standard. The top band is approximately 6,000 pairs. The second is approximately 3,500 base pairs, and the third is approximately 1,500 base pairs. Congratulations, you have just run your own DNA and gel electrophoresis experiment.
That's it.
So this is the presentation of Group 4 about the gel electrophoresis. So here are the questions. Number 1. Gel electrophoresis is used to sort DNA strands according to their blank. Where do you place the DNA samples on the gel? What makes the DNA move? Short hands move faster or slower than longer strands. Number 2. Place the steps on the correct order. Number them. Load DNA sample into the gel, stain the gel and analyze results, make the gel, hook up the electrical current, set up gel apparatus. Number 3. In the gel electrophoresis laboratory, follow the steps to make your own gel. Answer the questions as you go. Letter A. What is agarose made from? Letter B. Melted agarose is poured into a blank. Letter C. What is the purpose of the comb? Letter D. The black end generates a blank charge, the red end a blank charge. Letter E. The bubbles in the electrophoresis indicate what? Letter F. Straining the DNA will make it show up under a blank light. Letter G. What are your estimates for the number of base pairs in the three bands? So here are the questions. Ay, the answers pala. For number
So,
1,
number one, gel electrophoresis is used to sort DNA strands according to their length. Where do you place the DNA samples on the gel? You place the DNA samples into holes at the end of the gel. What makes the DNA moves? Electrophoresis is how we push the DNA strands through the gel filter. By adding an electrical current, we can make the DNA move. Short strands move faster than longer strands.
Place the steps in the correct order. Number them. Load DNA sample into the gel. So this is the third step. Stain the gel and analyze results. So this is the fifth step and the last step. And make the gel. So this is the first step. Hook up the electrical current. So this is the fourth step. And set up the gel apparatus. So this is the seventh step.
For this is the number. Hey, this is the number. This is the answer for the question number 3. In the gel electrophoresis laboratory, follow the steps to make your own gel. Answer the questions as you go. Letter A. What is the agarose made from? Agarose is a polysaccharide that is isolated and purified from agar or agar-bearing marine algae. Letter B. What melted agarose is poured into? A. The molten agarose is poured into a gel casting tray and a comb is placed at one end to make wells for the sample to be piped into.
So for the letter C, what is the purpose of the comb? The purpose of the comb in gel electrophoresis is to create wells to hold samples. Letter D, the black end generates a negative charge and the red end is a positive charge.
For the letter E, the bubbles in the electrophoresis indicate what? Bubbles mean the electrodes are connected, plugged in, and that current is flowing. So for the letter F, staining the DNA will make it show up under ultraviolet transilluminator light.
For the letter G, what are your estimates for the number of base pairs in these three bands? So I estimate 4 to 6 base pairs. So that's all for today. Thanks for watching.